Does everybody understand what he just said? We went from, this is 80%, and this is a power factor of 90%.
Is your resultant, correct?
Correct. So we have to add in, and this 80 Casey bars is represented right here as the amount that we're putting in to drop it down.
So how do we figure out the capacitor? The
You just see how many 15s and how many 25s go into it.
80, right?
So since it's 80, we could do, you know, 2 25s and 2 15s. Now the book, you noticed on the other one, it didn't do real close. It had other values which were lower, but those are still pretty close. When you figure out the actual power factors, you know, they still stick pretty close at that point. And remember, you can put as many motors in here as you want. You just have to total all the watts and all the bars. And then you have to correct all of those bars with some type of synchronous motors or so many capacitors. And so what they're finding out now is it's easier to it's easier to correct the power factor as you go instead of trying to see what the entire plant's doing.
Yeah.
Because if you're doing the whole plant like we had down at Geneva, we had these rows and rows and rows of motors and they click on and off. And, you know, that's fine and dandy, but is it better to stick a capacitor with the motor? So every time the motor comes on and it's running, it's correcting itself, and you shut it off, you shut the motor off and the capacitor. And so, that's what they're tending to do now. Yes?
So in the book too, it says 79.77. I guess for us it's okay if we're just rounding up. But practical, like if
Yeah.
you calculated that, you wouldn't want to do 2 25s and 2 15s, would you? Or would you just want to do 3 25s just to be safe?
Yeah, well, they always tell you not to go over, just like they say when we're putting amps on a wire. If
But
it's
you
just
can
a hair
kinda
over,
push
you
the
have to
limit a
go-
little bit?
Yeah. Yes.
Yeah, so would it be more safe to do 3 than 15?
Well, I would assume that they would make a judgment call and possibly go one less. And let's see what one less would do. Okay, so if we went 2 25s and 15s, give me what?
75.
Okay, 75. All right, so how would we figure out the,
That would leave you 4.77 bars or 5 bars left.
okay, so they leave you 5 over from what you had here, but we never calculated this, did we? So we'll have to calculate this real quick. So if we went from 300 and put 0.8, what would that give me for the volt amps?
$375K.
Okay,
And you have 300 watts, correct?
all right, and we've got the 300 kilowatts here. So how many bars do we have? And we've got the angle of 37 degrees.
225.
225?
Yeah.
Okay, so now if we subtracted how many off of this?
80.
Okay, so let's say we take 75 off of it. What angle does it give you? So if I take 75 off of here,
You have 150.
so you do the tan of theta equals what? 150
Yeah.
divided by 300. And then we can move this over the tan inverse.
So that would just give you the angle of 20 degrees.
And that's what's the angle, then we'll look at the power factor.
27 degrees.
Okay, so it gives me 27 degrees. And what's the power factor at 27 degrees?
89%.
Okay, so now that instead of being 90%, you got 89, which is really close. And that's probably why they don't go over, because it's not worth it for how much you pay for that. Does that make sense? So, yes.
Also, if you correct over too far, then you've got capacitance overcorrection messing up your power factor.
Right.
You've got to do something with the balance
Yeah, they never say go over. They always say never go over.
So is that one of the always, that is always
What did we say
in
about
this
always?
industry? Yeah.
It's always incorrect to say always. But it's one of the rules they just have, is they tell you not to go over, because you can see we went one less and it was still right there.
Okay.
So anyway, all right, we're in good shape here. Now there's a graph in the book, and what that graph shows you is that most engineers and power people, they would never do the calculation. They would just go to the table and they say, okay, I've got